One of the core strengths of the processing language is the ease by which graphics can be programmed. In this lecture, I'll show you how to visualize data from the accelerometer in the Arduino 101 board. I will discuss the 2D graphics primitives, colors, the structure of a processing sketch, and two-way communications between the Arduino and the host computer. Let's check it out. Hi, in this lecture I'd like to show you how to create your own custom graphics using input that comes from your Arduino. In this case I've got an Arduino 101, and one of the nice features of this Arduino is that it's got an accelerometer and gyroscope integrated into the Intel microprocessor on the board. So I'll be getting accelerometer data from the accelerometer, sending it data to my processing sketch via the USB serial port, and then visualizing the data. I will first upload the sketch to the Arduino, run the processing sketch as well, show you what the end result looks like, and then walk you through the Arduino and the processing sketches. So first, let's upload it to the Arduino. Okay, so that's done. And then start the processing sketch. I believe that this should be a 3 for my Arduino. Okay. All right. So I've got my little canvas, and as I am moving the Arduino in different directions, you can see that the graphics and the bars change accordingly. Another little feature that I've got integrated into the design, just going to clean up a little bit here, the circuit from the previous sketch. Just keep only what's necessary. Is that I've got an LED connected to pin number 9. So this one should be ground, and the anode goes to pin number 9, like that. So now if the processing sketch detects a strong vibration on the x-axis, then the LED turns on. It will not react for any vibration on the y-axis or the z-axis, but if there is a vibration on the x-axis, then that's detected by the processing sketch and the LED turns on. Alright, so how does that work? Let's check out the sketches. Let's start with the Arduino side. I've just taken one of the examples that ship with the Arduino 101 library, and I'll be talking more about this, about the details of the 101 and the library and the demo sketches in the section in this course on the Arduino 101. But what I want you to pay attention to mostly is the code that closely relates to the processing sketch that is running on the desktop. So after I get the readings from the accelerometer and I put the individual readings for the 3 axes in their own variable, what I do next is I create a row of comma delimited values. So I've got the x accelerometer value followed by a comma, followed by a y accelerometer value, followed by another comma, followed by the z accelerometer value, and then I sent over a new line. This information is sent to processing via the serial port. So that's a serial port to which the processing program is connected to and is listening to. If processing sends back any information, then that will be read by the Arduino sketch using the read instruction and stored in the response variable. The response variable is just a character, it's a single character. If this response value is a number 1, which signifies the fact that the processing sketch has detected a strong vibration, then it will turn on the LED, wait for 50 milliseconds. So they should be milliseconds, of course, not 5 seconds, and then turn the LED off. So that's all that is happening here. Because you've got serial communication, what you need to do is to get the data that you want to send to the processing sketch into a format that the processing sketch will be able to understand. And probably the easiest format is just comma delimited set of values. So that's what happens here. Just by the very fact that you are writing these values to the serial port, they are transmitted and they are communicated to the processing sketch. On the processing sketch, you can see, first of all, down in the console, the raw values as those are sent over from the Arduino. So this is the value for the x-axis, the value for the y-axis, and the value for the z-axis. And the sketch will take those values and split them to their individual values. So let's have a look at the processing sketch from the beginning. First, we import the serial library so that we can interact with the serial port. Then we import the Arduino library so that we can interact with the Arduino easily. We've got a few global variables set up, and then in the setup method we create our canvas, a 200 by 200 canvas. We connect to the serial port and we give it a name, port, clean it up, and then start reading. To read a line that contains a string from beginning to end, we use the port.read string until, and then you give it a condition until the end of the line. If you've got a partial line, we just clean up. We are still in the setup method, so we're not interested to do anything with the data that we have read so far. Inside the draw function, we check to see that we have a connection with a serial port, and if we do, we go and we take our reading. We read in one line at a time, and the text that we're in goes into the serial variable, which is a string. Then we start drawing. If what we received is not empty, so if we actually have content in the serial string, then we start creating the drawing inside the canvas. So first we set up the color. These are web compatible colors. You can choose colors by going to a web color, pick a website, like for example this one here, and you can just pick any of these colors, whichever one you like, and then copy it into your processing sketch. So that's how I chose these colors here. There's a hexadecimal RGB color scheme. Then we take the serial string and the content stored in it, we assign the comma as the delimiter, and then we split the values in this comma delimited set of values into an array of strings. So we are going to end up with an array of strings. We call it A, and in it we're going to have the three values from the accelerometer and the three axes, X, Y, and Z. So A at position 0, at index position 0, will have the X accelerometer value. Then A at position index 1 will have the Y accelerometer value, and at position number 2, index 2, will have the Z accelerometer value. Then down here I create the three rectangular shapes that you see in the canvas. So the first one is going to be a red box. It's going to have the X value represented visually, and I just set the dimensions for the rectangle. So the first two numbers make up the position or the middle of the rectangle on the canvas. So it's going to go at 0.2 of the total width and 0.5, that's the middle of the total height. So I'm placing this line right in the middle. And the next parameter is the width, so how wide I'd like the rectangle to be. And then finally, the last parameter is the total length of the rectangle. And I've just done a calculation based on the accelerometer value and the height of the canvas. And I've got a 0.5 so that the rectangle that I'm drawing is evenly distributed in the middle of the canvas, and it extends evenly up and down from that middle line here. Alright, next I change color. So the fill instruction basically allows you to set the color for whatever you're going to draw next. So next I'd like to draw the letters X, Y, and Z and like them to be black. So I use the fill instruction to change the color of the drawing that will follow to black. Then I set the size of the text, and I just use a text instruction to draw these three letters, and I control the positions like that. That's about it. As far as the LED is concerned, I just arbitrarily chose 0.5 value for the accelerometer reading for axis 0, axis X, and I just say that if the accelerometer value for the x-axis is over 0.5, then that should trigger the LED to be turned on. So if that condition is true, then I go to the port, which port, remember, is the object that represents the serial port that allows for communication between the processing sketch and the Arduino sketch, and I send out the character 1, which is then picked up by the sketch here in this line here. So I hope that this demonstration gives you an idea of the kind of things that you can do with processing and with an Arduino. So you could create applications that take sensor data and visualize them in interesting ways, or you can send feedback back to the Arduino and have the Arduino physically react to processing events and calculations. Of course, there's nothing stopping you from doing all the usual Arduino control stuff, like controlling motors through PWM, actuators and relays from your processing sketch. Don't forget the ability also that processing has to generate standalone applications that can run independently of the processing IDE.